All right, hello everybody. Welcome to the next video. We're going to be continuing our conversation about ions. Today we're going to be learning about ionic compounds, okay? So your objective for today is for you to be able to determine the chemical formula of an ionic compound, okay? And mainly what you're going to be doing is taking two elements and figuring out what is the name and or formula of that ionic compound that's formed between those two elements. Okay, so that is going to be our task. So what is an ionic compound? Well, an ionic compound is just a chemical or a compound, right, that is made up of two parts. Okay, a positively charged cation and a negatively charged anion. The name and symbol of the cation always comes first in the name or formula, and the name or symbol of the anion always comes last. So it always goes in the order of positive, negative, right? Or cation, anion. How do you do this? Okay, how do you determine formulas? Well, the one big thing that you must know is that all ionic compounds have to be electrically neutral, meaning that the overall charge of that compound must be zero. Okay? I've written out 4 steps that you can follow each and every time. If you follow these 4 steps, you can always determine the formula for a compound. Okay? It is a little bit complicated, but if you can learn the steps and practice the steps, I'm confident that you can be successful with this. Okay? Step 1 is to just write out both ingredients. These are usually going to be given to you. Okay? I'll show you some examples here in just a minute. Step 2 is to identify or really predict the ionic charge on both ingredients. Okay, that's going to be using the periodic table. Okay, so remember we've got these ionic charges that we labeled on our periodic tables last time. I've got this picture here in the notes here for you to use in case you don't have a hard copy of that yourself. Then, step 3, we need to determine the ratio of each ingredient needed to cancel the charges out. The overall charge of the compound must be 0. That's going to be the hard part, and that's going to be something you're going to want to pay attention to in the examples that I do on the next slide. Okay? And then step 4, you're going to want to write the chemical formula of the compound using this ratio that you determine in step 3. Okay? So, once again, we're going to be using this periodic table here to predict these charges, and we're going to use those charges to predict the ratio, which then is the formula. All right? So, without any further discussion, let's go ahead and get into some examples. Okay, so let me go through some examples for you, and I think this is going to help. Okay, so we need to determine the name and chemical formula of the compounds formed between these elements. All right, so let's look at number 1. We have these 2 elements here, sodium and chlorine. This is actually step 1, just writing out the ingredients. Okay, they've been given to me here. I'm just going to rewrite them. Okay, sodium and chlorine. That's step 1. Step 2, if you think back to the previous slide, step 2 is to identify or predict the ionic charges that are going to be on these different ingredients or these different elements. That's where you use the periodic table. Okay, sodium is in the first column. It's all the way off to the left of the periodic table. It's going to have a positive 1 charge. Okay, chlorine is sort of the opposite. It's all the way over here. It's almost all the way over to the right of the periodic table. It's in the column that has negative 1 charges. Okay, so step 1, write the ingredients. Step 2, write the charges. Okay, identify the charges on those different elements. Okay, now this is the tricky part. Step 3. We have to determine the ratio of these, okay, that gives us an overall charge of 0. In other words, how many of these, how many sodiums do I need to cancel out the charges on chlorine? Okay, it's like how many sodiums do I need to cancel out how many chlorines? We're trying to figure out like both of those numbers, right? Well, when the charges are equal but opposite, it's super easy. Okay, I just need one of these for every one of those. Okay, 1 sodium will cancel out the charge of 1 chlorine. Does that make sense? 1 sodium will cancel out the charge of 1 chlorine. So my ratio is just 1 to 1. All right, that means my formula is NaCl. Okay, another way to write this potentially would be Na1Cl1, but in chemistry, we don't really write these ones. Okay, if the number is 1, we don't write it. It's just assumed to be there. Kind of like in math, if you have x, you don't have to write 1x, you can just write x, right? It's the same sort of concept, okay? So that is the chemical formula, all right? I'm going to get to the names here in a minute, all right? I want to stick with the formulas for a while, all right? So let me clear this out, and let me go on to the second example, okay? So my ingredients are aluminum and nitrogen. That's step 1. Step 2, determine the charges, okay? Aluminum is going to have a charge of positive 3. Nitrogen is going to have a charge of negative 3. Okay. Once again, I'm getting that from the periodic table. The slide that came right before this with the big periodic table and those charges up at the top, that's where I'm getting those numbers. Okay. Step 3, this is the hard part, right? What ratio of these ions or of these elements do I need to cancel the charges out? Well, once again, if the charges are the exact same, but with the opposite sign, right? Positive 3 versus negative 3, then my ratio is just going to be 1 to 1. 1 aluminum will cancel out 1 nitrogen. So my formula is ALN. Okay, once again, I don't need those number 1s there, those number 1s, because, you know, the 1 is just assumed to be there. Okay, so ALN, that's my formula. All right. Now, let's look at a couple of situations where it's not going to be a 1-to-1 ratio. All right. So number 3 here, potassium and oxygen, my charges are going to be +1 and -2, right? I can look on the periodic table, find those elements. Those are going to be the charges, +1 and -2. Now, this is not going to be a 1-to-1 ratio, okay? Because if I said my formula was KO, all right, that would be 1 potassium, 1 oxygen. This does not have an overall charge of 0. The overall charge of this would be -1. Right? Oxygen has a -2 charge. Potassium is only +1. The negatives are winning, right? It's kind of like doing math. +1 - 2. That's -1. All right? Like literally, +1 - 2 is -1. We want the answer here in our formula. We want the overall charge to be 0. Okay? So we want our overall charge to be 0. So what does my formula have to be? Well, think of it this way, right? If I have 1 oxygen, then I would need 2 potassiums, 2 + 1s, to counteract the 1 oxygen. This would be a 2-to-1 ratio. Okay? This is the answer. Okay? My formula then would be this. K2, that means 2 potassiums, O. All right? Once again, I don't really need the number 1 there for the 1 oxygen. This is it. K2O. Okay? This formula has an overall charge of 0. That's what you're looking for. Okay? Let's do another example. All right? Magnesium and fluorine. Magnesium has a +2 charge. Okay? Fluorine, -1. Okay? So the question is, right, what's the ratio of these that I need to get an overall charge of 0? Well, magnesium's got this big +2. Fluorine's only -1. What if I have another fluorine? That works, right? 2 -1s will counteract at +2. This is a 1-to-2 ratio. So my formula is MgF2. Okay, 1 magnesium and 2 fluorines. This formula here has an overall charge of 0. And that's what has to happen in order for your formula to be correct. All right, last example. This is as complicated as it gets right here. We have calcium and phosphorus. Okay, calcium has a +2 charge, and phosphorus has a -3 charge. All right. Ooh, this is a tricky one. Okay, because right now the negatives are winning. Right, phosphorus has got that big -3 charge, and calcium is only +2. If I add another calcium, this doesn't work because now I've got like +4 total compared to -3. Yeah, this is kind of a tricky one. Well, look what happens here. What if I add another calcium that's positive 6 overall, right? And then if I add another phosphorus, okay, this gives me negative 6. This works, okay? This ratio here would be 3 to 2, okay? This is about as complicated as it gets, all right? My formula here would be Ca3P2, okay? So that is as complicated as it gets, okay? Ca3P2. You know, the ratios that you're going to end up with in all of these problems are either going to be 1 to 1, 1 to 2, or 2 to 1, 1 to 3, or 3 to 1, or they could potentially, like in this situation, they could be 2 to 3 or 3 to 2. You're never going to have 4 to 1 or 1 to 4 or, you know, 2 to 2, okay? Because 2 to 2, that would be the same ratio as 1 to 1. So these are all the possible ratios that you could ever end up with, okay? This is as complicated as it gets. And I tell you what, we're not even going to worry about the names for today. Let's just focus on the chemical formulas, and that's going to be what your entire assignment is about in Canvas, just coming up with these chemical formulas, okay? All right, thanks a lot for watching, and I'll be with you guys right after the end of this video.